You picked Python for robotics because it felt logical. Huge community, clean syntax, tutorials everywhere. And I get it. But here's what those tutorials never show you. The moment your robot leaves simulation and hits the real world, you stop being a programmer and you start being a systems engineer. Python was never built for that world. The language you learned to lower the barrier became the ceiling. And the worst part is, most people don't figure this out until they're 2 years in and their code is still breaking in ways they can't explain. So let's fix that right now. The timing problem. Every piece of software you've written has one thing in common. Timing didn't matter that much. Your web app responds in 200 milliseconds instead of 50. The user barely notices. Your script runs a loop slightly late. Nothing breaks. Robotics kills that assumption completely. A robot arm moving at speed needs instructions at a precise, guaranteed interval. We're talking every single millisecond, without fail. Miss that window by even a fraction, and you don't get a bug. You get physical instability. A machine that oscillates, that, in an industrial setting, is a safety violation. This is called hard real-time, and it's the first wall Python runs straight into. Python runs on an interpreter. That interpreter sits between your code and the hardware, translating your instructions in real time. That translation adds delay, unpredictable delay. You write a line of code and you genuinely don't know the exact microsecond it executes. In a web app, that's completely fine. In a robot's control loop, that unpredictability is the problem. C++ doesn't have an interpreter. It compiles directly to machine code. The processor runs your instructions immediately. That's not a small difference. That's the entire game. The hidden pause. Now here's the part that actually surprises most people when they first hear it. Python manages your memory for you. Every variable you create, Python tracks it. When you're done with it, Python cleans it up automatically. That sounds helpful. Here's what's actually happening under the hood. Python runs a background process called a garbage collector. Its job is to find unused variables and delete them to free up memory. The problem is the garbage collector decides when to run, not you. It pauses your entire program, does its cleanup, then lets your program continue. For most software, that pause is invisible. For a robot's control loop running at 1,000 cycles per second, that pause is catastrophic. Your loop just died mid-cycle because Python's internal cleaner had other plans. Think of it this way. You're a chef mid-service, kitchen is slammed, tickets are flying. And randomly, without warning, someone cuts the power to your station for half a second to do maintenance. That's garbage collection hitting your robot at the worst possible time. In C++, there is no garbage collector. You manage memory yourself. You say when data gets created. You say when it gets deleted. You are in complete control of when things happen. That's not extra work. That's the requirement. The hardware wall. Here's where Python doesn't just struggle. It physically can't exist. Robots aren't just computers running Linux. A huge portion of real robotics happens on microcontrollers. Tiny chips embedded inside joints, sensors, motor controllers. These chips have kilobytes of RAM, not megabytes, kilobytes. The Python interpreter alone needs megabytes just to start. You can't fit the language on the chip, let alone your actual code. This is why embedded engineers don't debate Python versus C++. The hardware makes the decision for them. C++ compiles down to bare machine instructions. No interpreter, no runtime overhead. It fits on the chip and runs directly on the processor. If you ever want to work close to the physical hardware of a robot, Python is not an option. What you should actually learn. Here's the practical part, and I want to be clear. Don't try to learn all of C++. That's a trap too. Focus on two things. First, learn manual memory management in C++. Specifically, how stack and heap allocation work, and what pointers actually are. A pointer is just a variable that stores a memory address instead of a value. That's it. But understanding it means you control exactly where your data lives and when it moves. That understanding is what separates someone who scripts robots from someone who builds the systems inside them. Spend 3 weeks just on this. Build small, ugly, boring programs that do nothing except practice this. That's the work. Second, learn ROS2, Robot Operating System. It's the industry standard framework for structuring robot software. Sensors, actuators, compute, communication between systems, all of it runs through ROS2 in professional robotics teams. And ROS2 is C++ first. Its core is written in C++. Its real-time extensions are in C++. Python wrappers exist, but they're convenience layers sitting on top of the real architecture. Learn the real architecture. Where? Python actually belongs. Once you have that foundation, use every tool available to you aggressively. And yes, that includes Python. Python is genuinely useful in robotics, for high-level orchestration, for logging data, for visualization, for rapid prototyping at the system level where timing constraints don't apply. That's the correct role for Python in a robotics stack. The top layer, not the bottom. The mistake isn't using Python. The mistake is using Python without understanding the layers it's sitting on top of. When something breaks at the hardware level and you don't understand memory or timing, no tool helps you. You're just guessing. Foundation first, tools second. That is the right order. The part nobody says out loud. Robotics is harder than most software fields. That's not a myth. It's true. You're interfacing with physics, real latency, real inertia, real consequences when something goes wrong. The field demands you understand software, hardware, and control theory at the same time. But here's the reframe. That difficulty is exactly why the field isn't flooded with people who figured it out. Every hour you spend fighting a memory bug, every time you trace a timing issue for 2 hours and finally understand why it happened, you're building intuition that is genuinely rare. You're not falling behind. You're doing the work most people quit before finishing. Stop scripting. Start architecting. The machine needs a brain. Go build one.